the glare on the board if I open this window? See?
Not that much.
So the first question is you using the graph, guys.
It's going left to right down. Oh, that's right. That's right. Like, would it not be from here until the turning to like one? So it would be it's the same. Not in. Yeah, we eat that. Because you know the eggs. Yeah, that's why we give it to.
Right, so if we look at the first question, okay, what's this question saying to you? It's saying to you, when is the gradient what, guys? Negative, right? So I've highlighted on the graph where the gradient is negative. They said it cannot be equal to 0, so you cannot include the stationary points, right? Okay, so the region on the number line, okay, that we're looking at is from here, open dot, there in red is your answer on the number line. That's your first region, right? Your second region is from there to there. Right, so, Amy, how did you write this answer?
If x is less than -4,
Yep.
or x is greater than 1.
Good. Did anyone do interval notation?
Yes.
How did you do an interval notation, Taylor?
X is an element of bracket negative infinity to -4 bracket or 1 to infinity.
High five yourself. Right, well done. Okay. Real good with that, guys. Okay, carry on.
Why did you say it was making a full graph? So the parabola is when stationary is next to this. What do you say? Those are the x-intercepts of this graph. Yes. It is. I know it's a relationship. Yes. Okay. Because it's nothing that's two. Yeah. So it's -1, 1. Like yes. I don't know if it go out. I think the stationary points of the graph.
Yeah, the stationary points are the intercept.
Yeah.
The stationary points on the cube graph are the x-axis.
I did, but I feel like I'm not doing it. So the stationary, well, all of this can be simplified into a straight line. The x-intercepts of the parabola, which is the derivative of okay, so this is f of x. And what we're trying to do here is f dash. So the relationship between those two graphs is that the turning the stationary point on f of x will be the x-intercepts on f dash of x. And f dash of x is always going to be so x double dash of x is always going to be dash.
Oh, okay.
Okay, that makes sense. So -4 and what's this? -2.
No, 1.
1, yes. Why should I read that as -2? 1 will be the x-intercept of the parabola. Yes. Yes.
Look at the shape.
So it's
Okay,
negative.
It's starting negative, ending negative, right? Okay, so if it's starting negative, ending negative, it means that in ax cubed, that number is a negative number, right?
Yes.
So when you differentiate, it'll be negative as well. So it must be a sad parabola. Okay. Guys, get an idea, so for this one, get an idea in your head first of what this thing's going to look like, right? So listen for a second, please. Okay. This starts with a negative gradient and ends with a negative gradient, right? So if the function was ax cubed, blah, 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 right? A must be a negative number, right? Okay, if I differentiate it, okay, you're going to get something of degree 2, so it's going to be a parabola. but it's going to be negative something x squared. Do you agree with me? Okay, so my shape, in my head I immediately think, okay, I'm going to end up with a graph that looks like that. Okay? Then I say, I'm drawing a graph now where the horizontal axis, okay, are x coordinates, but the vertical axis are not y coordinates, they are gradient values, they're derivatives. Okay, so we're sketching on the y-axis goes the gradient of the original graph. Okay, so first of all, where are the gradients equal to 0? The gradients are equal to 0 at A and at B, right? Okay. Okay, too late, sorry.
Too late.
Yeah.
That was mine.
Okay,
that I
good.
collected.
No, that's best, it happens.
Oh, sorry,
Okay. So, okay, it happens. Right, okay. So guys, where are the gradients 0? At negative 4 and at 1. So, on this new graph, the y coordinates are gradients, right? So negative 4, 0 must be a point on this parabola, right?
Oh my gosh, that makes so much
Okay.
sense.
And this coordinate is a gradient as well. So when x is 1, the second coordinate now are gradients, right? So when x is 1, what's your gradient at that point? It is 0, right? So negative 4, 0, because now your coordinates are x and then the gradient of f. You with me?
Yes.
Okay, so it's negative 4, 0, and when x is 1, the gradient is 0. So negative 4, 0 lives here, and 1, 0 lives here.
We have to try to show that it's
Okay.
okay.
Are we happy with that? I know it's got a negative shape. Now, okay, where does the maximum of a parabola occur always? This is what I said yesterday about symmetry. In the middle, right? So what is how far is that distance?
-2.
How far many hops does the rabbit have to do to get from negative 4 to 1? 5 hops, do you agree? So halfway is 2.5 hops, right? Do you agree?
Yes.
So you calculate negative 4 plus 2.5 and you get negative 1.5. The y coordinate you don't know. Okay, they haven't given us enough information. Okay.
Must you make it up?
Sorry?
Should we make it up?
So it's just going to, but it's going to be above the axis, do you agree?
Yes.
So that's going to
Did
be,
you grab state mine?
what? Your
My
upper,
copies.
your upper palm, that's up in this thing. Okay. So that x is equal to, what did we say? Negative 1.5, right? Okay. And then my graph is going to look like this. Okay. Now, just to show you how it links up, it's not part of this question, it might come up, I don't know. Okay. In that region over there, okay? In that yellow region, what are your gradients? Your gradients are what? Negative, right? To the left of negative 4, your gradients are negative, right? That's because over there, why? Because what are your y coordinates on this graph? They're gradients, right?
Yes.
Okay, and it gets flatter and flatter and flatter. That's why the gradients get closer to 0, right? Does that make sense? Okay, then in this region in brown here, between negative 4 and 1, what are my gradients? Positive. The y coordinates on this graph are gradients, right? So between negative, the y coordinates here are positive. You with me? Okay, the maximum gradient occurs at your point of inflection. Okay, because it gets flat, steeper, 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 then it starts getting flat again. It starts getting back closer to 0, right? Okay, and then after 1, what happens to your gradients? Your gradients are negative, so this graph is below the x-axis. Kind of see how they link up. Okay, they love these kind of questions. Okay. Yeah. Let me just see the memo where they allocate marks.
So they'll never ask you to specifically use like interpolation or the other.
No, never.
Okay.
But you have to understand both in case they come up somehow. Okay, what question are you doing? Okay, shape, x-intercept. So the only allocating marks, the shape and the 2 x-intercepts get you the marks. You need to have to put that negative 1.5. Okay, right, off you go. Next question. Come. We'll have a break in 15 minutes.
This is between the equation and the unless you potentially
Yes, I'm in the math. I'm in the math. Yes.
I don't want to run out of math. With like what the zoo.
Guys, come on. So, for C, okay, you're going to have to use your graph for C. Okay. Try C and D.
This should just how much do you have to see? How are you going to use it?
Speak to your neighbor. The question is saying what, guys? What's a root? It's an x-intercept, right? Okay. If I may change the word root to x-intercept, people would do better in this question, right? But a root, a solution, is an x-intercept. So what's this question saying to you? It's saying to you, if you take that graph, this is question C, okay? If you take this graph that you've got and you move it down, move it by k units vertically. Doesn't necessarily be down, right? Okay, if you move it k units vertically, how must you move it so that there will now only be one x-intercept? It's not a single answer, it's going to be a region. There are two ways you can move it. Try to think about it.
You move it down by
You can move it down and you can move it up to get one x-intercept. You can move it down and up so that you only get one x-intercept.
We can move it up by Q or move it down by Q.
Speak to your neighbor. How must we move this so that I only get one x-intercept?
We can say I don't have one because every one is in terms of the this thing. Yeah. So we can move it up by either Q or move it down by P.
You have one.
This is F of this is F of this is F of this. So you can move it up. Or you can move it down. But this is zero. Okay.
But we need to specify this how much it is.
Oh, you're saying K is bigger than less than. It has to be, yeah, it has to be greater than that.
Yes, so K must be greater than
Oh, yeah. Oh, P. Must be greater.
Okay, let's have a look at this one. Okay, you just got to be a little bit careful. Okay, so your one option involves moving the graph down, right? Okay, if I'm moving it down, to get one x-intercept only, okay, what's that distance? It's P. I have to move it down by more than P, eh? Okay, so I have to move it down by more than P. Okay? Right? So now the question said you've got f of x minus k, so we have to be a little bit careful. Okay, so what does P have to be?
P has to be.
Well, think of a number. Okay, say this was the number 3. Okay, you'd want to end up with f of x minus, for example, f of x minus 4, right? Would work, right? Okay, so what does P have? What does k have to be? Greater than P, right?
Would it be greater than or equal to?
No, it's greater than, because I only want one answer. If it was two solutions, okay, then you'd include P, right? So k must be bigger than P. That's that first bit over there, right? Got to move it down more than P units, right? Okay. Right, then Q. Okay. How do you have to move it upwards? So if you move it up, you have to move it up more than Q, right?
Yes.
Okay. But be careful, it's a bit tricky because Q is the y coordinate, right?
Yes.
So this actually is, this is a bit confusing, a negative number, right? Am I right?
Yes.
Okay. So you have to move it up, okay, more than that number. More than positive Q, right? Okay. So
Is it a negative?
careful. Okay.
Is it a negative?
So let's think of a number. Okay, my head's spinning. Okay, so if this was -7, okay, what would work?
8.
K plus 8 would work, right? Okay, do you agree with me?
Only if it makes sense.
F of x plus K would have to be equal to, K would have to be 8 would work, right? Because K would equal to negative 8 would work.
Yes.
You with me?
Yes.
Okay, because then you get f of x minus 8, which becomes f of x plus 8. Okay? So, what does K have to be? What does K have to be then in this case? K has to be less than Q. Let's see if it makes sense. We'll use the number. Okay, so if you get stuck, look at a number. Okay, if we looked at that
Oh,
8.
if Q was
Okay,
negative.
Q is negative 8, right?
Q is -7, but
Okay.
now K would be negative.
What does the memo say? Yeah, K is less than Q. Does that make sense? Because, okay, it's a bit confusing. Okay,
No.
alright. But you got the idea, guys. Those questions also come up about vertical shifts. Okay, right. Right, try D.
Okay, down and
We're going to go to 9:55 and I'm going to go to a meeting for 10 minutes. Okay.
Oh, wait, concave down.
Are you sure?
So then what you say is, but we notice the x, we know the x is common by 1.
Oh yeah, because we said that is the middle of the update.
Okay, so the x has to be less than,
So it would be.
this is more than
Yeah.
negative. Oh, you're doing it. Wait, I'm doing it. No. Oh, less than. Oh, yeah. Sorry,
What's this point then? What's this?
Wait, what
it's not concave up.
concave
That
down?
was the best decision.
Oh, we can just say it.
Remember, this x coordinate here is negative 1,5, eh?
Ah, yes.
Because it's in the middle, right?
Oh no.
Okay, it's always in the middle of the two stationary points. Are we happy with that? Okay, so the point x coordinate of your point of inflection, your point of inflection is when your graph changes concavity, right? Okay, so we're looking for this blue region where it's concave down, is where it's sag, the tangents are above the curve. That is the region we're looking for. Okay, you never include the point of inflection. There's no concavity at the point of inflection. Okay? So, what's my answer going to be then, guys? So there's my answer on your blue here is my answer on the number line, right? So your answer is going to be x is greater than negative 1,5, or you could say negative 1,5 to infinity. Okay. Are we happy with that?
Are we doing question 8 now?
Yeah, try start question 8. 8 minutes to a break.
That's so real.
Maybe.
Question 8.